Hello, welcome back to Computer-Aided Measurement and Control online class. In this discussion, now we are discuss about pulse width modulation or PWM. In this pulse width modulation, we are going to generate some kind of average voltage, or we call it the output voltage, for later before we do discuss about the servo motor or DC motor for next lecture. So I think this pulse width modulation is very important for you before we are going to servo motor and DC motor. So in this objective, and I just teach you about in this topic in the you can see in the chapter 4 of our textbook, and it's about the analog output. Okay, and the objective in this online lecture is to understanding first pulse width modulation or PWM, and also analog output using Arduino Uno, and learning how to deal with RGB LED. In this experiment, we are going to use the Arduino Uno and potentiometer, and this one is type kind of RGB LED. And maybe in your Arduino kit you have this kind of thing, RGB LED of the common cathode, and as this one is also same with the internal resistor installed in this PCB board. So you just put in the cable directly, and also you need also LED, of course. All right. So going to next slide. In this lecture, our topic is the analog write function. In analog write function, is basically to use to set the analog voltage output value in the digital output pin. Only this kind of pin, and this timer pin in 3, 5, 6, 9, 10, 11 pin for generate the pulse width modulation in Arduino Uno. Okay, and the syntax is you just give the pin in here analog write, big W write pin, and the value. The value is this one between 0 to 255, because it is 8 bits value, so the range is total is 256. So the range is between 0 to 255. So for example, in here, for simple calculation, if you want to put the output value with the value 63 decimal value between 0 to 255, so maybe averagely the voltage is about 1235 voltage output value. Okay, this one is very simple analogy, so simple calculation. I think everybody can understand. So in next, in your textbooks, there is the timer pin, which is timer. There are 3 timers, timer 0, timer 1, and timer 2. A special timer in timer 0, it's working with 980 Hz, and timer 1 and pin 9 and 10, and also timer 2 is as equal frequency with 311. Okay, for timer 2 is a timer used to generate the pulse width modulation for generate average load voltage or analog output. So the we are already talked about the function, how to write is similar. Analog write is a pin of can generate pin pulse width modulation and the number between 0 to 255. In previous slide we already discussed about it. And in timer 0, this is calculation of period is about 1.020 millisecond, and timer 1 and timer 2 is a double period. Okay, so the next is discussion what is actually pulse width modulation in both. Oh, sorry, it's one mistake. Pulse width modulation. Okay, just save it. Okay, I'm sorry. So until when? Where we are? Okay. Pulse width modulation is actually the modulation technique can create a digital variable with pulse, and this pulse can represent the amplitude of analog output signal. If you take it average value, it will have the analog output signal averagely. And pulse width modulation provides a digital output pulse waveform with an adjustable high mark period. Okay, the high output state is commonly called a duty cycle. Understand? Only high output state is commonly called a duty cycle. This is very important. Maybe only high output state, we call it a duty cycle. How many percent the pulse of width modulation is called it? Maybe can 10% or 50%, 60%, something like that. We call it using terminology of duty cycle, which is the high output state. Okay, this one, a duty cycle is expressed as percentage of overall period of the pulse wave. Maybe for example, 50 duty cycles gives an equal a space ratio of the signal. Okay, I took this picture from your textbook. As we can see, this one is digital output, high and low, and this kind of signal, maybe it's using pen, is okay. Actually, your signal is like this. Okay, so and the book is, I think, very not good to present. Okay, actually your signal is like this, high and low. Okay, this high signal is called it only duty cycle. This one is duty cycle. I just type a DC. Okay, duty cycle. And this from here to here is called it a period, which is you already know the frequency for timer 0 is about 0.20 millisecond, timer 0, and timer 1, 2 is about double period, something like this. Okay, let's call it a duty cycle for only high signal. So you doesn't care about the low. Okay. So in the below figure is the stage, and if you have the 50% duty cycle, this is duty cycle. If you have equal signal duty cycle, this one is 50% of period, this one period, and this one is half period. The duty cycle 50%. The output value is averagely is in the middle of the signal. So you have about 2.5, sorry, 2.5 volt in average value for analog output. I hope you understand. I will erase this. Okay, for next, maybe it's more clear for you. This one I just also took from your book. In the left figure is I type wrong every time. Post with modulation. Okay, I'm sorry again. Okay, this one is post with modulation, post for left figure. As you can see, this one is full high on. This one duty cycle 100%. So the output voltage is averagely also 5 volts. This one might be 5 volts. So if you use the duty cycle 80%, something like this. Okay. This one 80% duty cycle. This one is one period. Okay, this one period. This one is 80% of period, and the output voltage is averagely around here. Okay, this output voltage is averagely around here. How about 60% is same? This one is digital signal of post with modulation. Okay, with 60% duty cycle, and this one 40%, and this one is average voltage for 40% duty cycle for analog output, and this one is 20%. Okay, and it's very low output voltage, and this one 0 duty cycle, nothing. I think this one is not 0. This one I think about 5 or 1%. I think 5% because this has signal. I think this one is 5%. I think this is wrong. I think 5% or because it has signal. If 0%, 이거는 없어요. Okay, so if we observe the signal in using oscilloscope, oscilloscope, maybe this kind of device. You have a monitor here, and this one is channel. This one is many buttons here. This one is call it oscilloscope. Okay. This one is duty cycle 10%. There is a signal here. This signal is only high and low. Okay. This one is 20% duty cycle, 30% duty cycle, and this one is 40% duty cycle. This one is 50% duty cycle, 50, half of period. This one is period. This one is 50% of period, which is high. This one, okay, duty cycle is, we call it only high on. So this one is 60%. Okay, 60%, and this one is 70%, 80% like this, and 90% like this. This one is pulse width modulation for analog output. I just took from book using timer 0 and this frequency and this variation of duty cycle, and this one is period, is averagely about 120 millisecond. You divide it with 980 hertz period. Okay, and this one width of this one width of on. All right, okay, and this one maximum voltage of the, I think, of high voltage, amplitude and frequency, and this one is average value of pulse width modulation. As we already discussed in previously, the pulse width modulation, if you take it average voltage, it can generate the average value of analog voltage. Depends on duty cycles. All right. So we begin next experiment. First experiment. Because I don't have oscilloscope, not available, so we use the Arduino to check the signal, pulse width modulation signal, through analog input. Analog 0. This one we just connect the we want to check the pulse width modulation signal according to the duty cycle. Okay, we just connect this pin 11, which is the, what is 11? Timer. This one timer 0. Okay, timer 0. And this one I think timer 2. Timer 1. timer 2 is 11 and 3. This one is timer 2. Okay, we use timer 2. Check again. Yeah, is 11 is timer 2. Okay. We use timer 2 with a frequency about hertz. I'm correct. 480 hertz. 490 hertz. Sorry. Yeah, 490 hertz. Anyway, you just connect and just see the code. I hope you don't feel boring with this lecture. And okay. So constant byte pin PWM pulse width modulation, we set pin 11. Okay, and constant byte pin analog, we use analog output 0 and just set the V reference voltage reference as 5. We already study about the analog input, right, for previous lecture. Okay, in this experiment we just set how much duty cycle as the input on the serial monitor. So we need the duty cycle variable, and value is the analog input value. So we need this variable, and we want to convert to voltage, decimal to voltage. Of course, we need the float variable for voltage. Okay, in void setup, just serial begin 9600 as usual, and in the beginning we write using analog write. We already studied this one function to generate analog output using pulse width modulation. Okay, just set the pin 11 and we just value 0 is nothing. 0 is 0 volt. We just set first 0. Okay, it will 0 pulse width modulation, duty cycle 0, and in void loop first we have to read the analog input. So how to do using analog read, and set the pin is 0. Okay, I want to change the color. Is 0. Okay, and convert to voltage. Just do 5 voltage divided the decimal value 0 until 3 for 10 bits for analog input. Okay, you already learned this, already studied, and just print the voltage value using serial input. Okay, so we just measure the pulse width modulation input signal using analog input A0. We want to see what is voltage input from pulse width modulation output 11. And then in this function, we want to set the duty cycle using serial monitor. So in here, if serial available, serial.available, okay, check the serial monitor available for input. Okay. So in here duty cycle, we check the number, first integer, first int. So only number, and the constraint is set the duty cycle. Lower is 0% to 100%. You just give input from 0 to 100%. And then this duty cycle convert to decimal value of 25500. Okay, by simple calculation, duty cycle multiply maximum value divided maximum value of duty cycle. This one I think very easy. And then we generate the pulse width modulation for pin 11. Depends on how much duty cycle we give input in serial monitor. This one number. Okay, this one is pin 11. Okay, I hope you don't confuse this, and we set any number for duty cycle from 0 to 100 duty cycle. How many percent we set in serial monitor. Okay, I hope you don't confuse with this code. Okay. So we come back to next video first, and this one use a serial plotter, and this one channel command. This one is 50% I think, and we set the value 80% in here. Change the duty cycle 80%, something like this, and 20%, something like this. Okay. Using serial plotter, not serial monitor, serial plotter. Set 50% first. The pulse generation can be like this, 50% period and 80% duty cycle, and then typing here 20% duty cycle, change it the value of duty cycle. Can check the output voltage from pin 11. Okay, I have the Arduino on my table. Okay, already set everything in here. Okay, now go to the program. Oh, where is it? Program. This program same in PPT. Okay. Maybe I will repeat again. First is pin, parameter, and variable. You set this variable and serial communication, and you first set the pin PWM 0 first, and we want to measure the pin 11 and plot in serial monitor. Let's convert to value of voltage, and then we check the serial monitor by giving input the duty cycle, how much percentage we give it from the serial monitor and generate the PMW based on the duty cycle. Okay, so this one port 5 and you just upload this one. And we have to check the cable first. Connect the pin 11 to A0. Okay, I already uploaded this one, and you can see the serial plotter. Go to Tools and Serial Plotter. Control-Shift-L. Okay, this one is serial plotter. It's because we put the pulse width modulation first beginning is 0. Okay. And give the any value in here. See the input. First, I'm going to put the 10% duty cycle and click send. And this one is voltage for 10% duty cycle. This one is 20%. See, I type this input and just send, click. And of course, the period will increase for high. In here, you can see 30%. This one is 30% duty cycle, 40%. Okay, and this one 50%. This one is 50%. We're going to 60%. This one's 50%, 60%, 70%, 80%, 90%, 100%. 100% is 5 volts is on. Okay. That is pulse width modulation for pin 11. Because we don't have oscilloscope in here, we use the Arduino itself to check the output value from pin 11. Set duty cycle. If 0 duty cycle is give the 0 voltage. In the book there is a peak, something like that. I think it's wrong. How about 5%? Is 5%? This one is 5%. There is a signal, very little signal generate for 5%. Okay, anyway. That is pulse width modulation. Okay, I think very easy. Okay, this one is pulse width modulation to generate the average output voltage on the using timer function in Arduino. Okay, for next experiment, we are going to fading the LED based on the analog output signal variation. Okay, I will end this video and I will make it next video again. Wait a minute. Okay, for experiment 2, I follow textbook page 107 And this one, we connect LED on the pin 11 for timer 2, timer 2, timer 2. Connect to LED and resistor, of course, Johang. You call it Johang, is it? And we are going to fading the LED based on the output value of pulse width modulation. Okay, just simply connect to resistor to 11 timer 2 and this one LED and go to ground. Very simple connection. So in code, of course, this one is set pin MW. Okay, this is set pin. And in the textbooks, there is no serial monitor, but in here I use the serial monitor to check the value of output in the for loop. Okay, so we need this to check the value of the LED. So in void loop in your textbooks, we are doing actually output of pulse width modulation from 0 to 255 with increment of 5 decimal value. This one is increment by 5. I plus equal 5. Its meaning is the same. I equal I plus 5. This one is equal equal algorithm. So this one is put the LED is 11, set analog right, and this one value I from 0 to 255 with increment by 5. Sorry, I equal I plus 5. And we check the value of I by serial print ln to check in serial monitor, display in serial monitor the value of I and delay. And then we put the value PWM 0 means LED off. Maybe it's annoying using here mouse. I will buy a silent mouse maybe. And delay 1 second. And this one is we want to fading the LED from value 255 to 0. Can here read in here 255 to 0 with increment minus 5. Okay, so I minus 5. In this algorithm, using like this is equal, same. So analog right, pin 11 and the value of I and serial print, display the check the value of I and delay 100. Okay, and then after that LED off for 1 second. Very simple. Okay, I wish you understand. All right, can we check the video? Okay, this one is video experiment from 0 to 255. So 255 is 0. This one is serial monitor. Check the value, decrease, and then increase. We can play together. If we play together, it's very interesting. This one is 255 and decrease. Oh, this is more faster. I record separately the video, so it cannot be together. Okay, for clearly we do live in here. I have the LED in here. Okay, and this one is code is similar in the presentation. Our presentation, I will explain again. This one is pin 11. Okay, and in void setup, we want to display the value of I. So set the serial communication is very standard in here. And void loop, this one increment by 5. Okay, from 0 to 255. I less than 256, or you just type less than 255 is same. Anyway, this one is the same. Okay, so analog right in LED, I generate PWM signal, analog right, and pin number, comma, the number decimal between 0 to 255. Okay, and then serial print, check the value of the I. What is I actually? This one. Okay, and then delay 100 millisecond, and after loop you off the LED. In LED, set the PMW value decimal is 0, no matter, is no problem. And this one, loop for 255 to 0 by increment minus 5. This one. You can type this same like I equal I minus 5. You can type like this is I think same. Or just using this, I think this one is better. Okay, analog right anyway. Analog right pin 11. This one 255 value from 255 to 0, and display serial monitor delay, and then off the LED. Okay, that one is sketch and upload. Uploading, done uploading. I have to change the cable. There is a lagging in video. I don't know why. I think just close this. Hmm. Why this one is doesn't appear? Oh, very strange. Very strange. Oh, sorry, very strange. Very strange. I think it's fail of my video. Oh, very strange. Mm. Forgive me, my video has lost connection. Oh, very strange. I think we have to set the Wi-Fi. Sorry, where is my Wi-Fi? Sorry for your waiting. I should be using Wi-Fi. Okay, now it's connected. Try again. Ah, really? Are you kidding me? Device IP is same port. Are you kidding me? Okay, I will come back after if I solve this. Wait a minute. Okay guys, I already solved this problem. So now in experiment 2, I explain again. This one is pin 11, okay? And this program is similar in PPT. I think I already explained, and just upload this one. And this one is experimental setup in my desk, on my desk, and you can see the LED already blinking. It is the same program. Okay, it's done uploading, so you can see the LED is change the value based on the PWM signal, and going to reduce the light. You can see in off the light, you can see the clearly the LED become more brighter, and off and come reduce the light, something like that. Anyway, you understand, I think. Okay, forgive me about that. This my connection is not very good. Anyway, this experiment 2. I think you can practice in your home using this program. This program is basically change the value of a PWM from 0 to 255 by increment 5, and print the serial monitor. Okay, and off LED for 1 second. And this one change the value from 255 to 0 and LED off. And I think it's better if without the LED off. I think it's more beautiful. Can upload, and done uploading. You can see the serial monitor. The value is increased. I turn off the light. You can see the LED is decrease the light and increase again like this. Maybe the delay is can change this delay. Maybe 500 millisecond. Upload again. See the LED more brighter, more slower, and then decrease the number of VMW. Oh, this one increase now. Still increase. VMW. This one is maximum, and then decrease the number. So the light become more low intensity. See the now off. Something like that. I hope you understand this experiment. I think this one, if I plot again with a delay, more lower delay, and see the LED, more faster brightness, and lower brightness, something like that. Okay. Okay, now going to next experiment. Just leave it this. Okay, this one is the video, you already watched it. So going to next. So next experiment, still in experiment 2, but this time we are going to add the potentiometer in here for channel A0 in here. The schematic diagram is similar from the textbooks, page 108. So the code is, I think I changed a little bit to check the value of the hot value variable. So we check the serial begin. Okay, first the pin value, pin analog A0, and you also know pin LED for timer 2, pin 11. And then in void setup, serial communication, serial begin 9600, and void loop, we read the analog read pin A0, this one, pin analog A0, okay, analog read, store the value in integer value variable, okay, this one conversion to value 1023 to 255 maximum, okay. In this case, the analog read is 0 to 1 to 3 because it's 10 bits, okay. We want to convert 0 to 255. So using this equation, value out, and then for analog write, pin LED 11, okay, out value based on the calculation out value. And then we display the value and then delay. Okay, I think it's no problem with this. So this one is video. We check it when we rotate the LED more brighter. Okay, this one is the value of the out value variable. So changing the maximum to 55 and then decrease when we rotate potentiometer counterclockwise, I think. Okay, so we have same program in here, constant byte, pin analog 0, and we have in here on my desk LED still on because previous program. Okay, this one is same, serial begin, serial communication, and in void loop we read the analog read for potentiometer. This one potentiometer. Okay. Then analog A0, this one save. And the value should be convert. We have to convert to in range 0 to 255. So using this equation. Alright, and then generate PWM, pulse width modulation based on this value from range 0 to 255. So we just check the value in here and display on serial monitor and then delay. Alright, so we just upload, and upload the program. Now we can rotate the potentiometer. Maybe light is on. Is my finger. This one is oh sorry, we have to put the cable for potentiometer. Connect to A0. So when we rotate this LED will more intensity more because the value is increased. Oh sorry, display the. So this one is now maximum value because the potentiometer give the value 1023. So we can reduce the value. Okay. Maybe light is off. Same brightness if light is. I think it's better like this. Okay. See the intensity of LED changing when I rotate the potentiometer. Okay. Can you get it? Because it depends on the value of pulse width modulation duty cycle. All right. Okay, this experiment I think very easy for you. You can practice also in home. Okay. That one is experiment 2. I think you have, if you have any question, you can ask me in contact. All right. Okay. We watch video again. When we rotate this one, the LED become more brightness. Okay. So now we are going to work in RGB, red, green, blue LED. Okay, in red, green, blue LED is fundamentally a LED package which consists of red, green, and blue LED. There are two kind of LED, RGB LED. I mean, first is common anode or common cathode, which is ground is in here, and common anode is positive. In this schematic, there is no internal resistor, so you should install the resistor together with this pin. All right. Okay, if these three internal color LED are combined, we can create a combination of color. All right. In this picture I took from this link. You can click this link and you can read what is actually RGB LED. Okay, it consists of red, green, and blue LED. And this LED we drive using pulse width modulation signal and change the intensity of the light of the three of LED. Okay. And this one is a package in your Arduino kit. This one is RGB LED you can find in your Arduino kit with the built-in resistor on the PCB. And to generate the color, you just activate for example, in here red, just giving value the PWM for red 255 maximum and green and for the middle, because of course this is red, green, blue, and pin green is in the middle and red is pin first in here. So activate this 255 first for red and green, middle, and blue for the last. Okay. For cyan color, combination between green and blue. So this green and blue combination will give new color cyan. And the magenta color with red and blue. Okay. And yellow, red with green. If both are all activated, give the color of white. This one is hexadecimal value. You can activate also using hexadecimal value, but I think it's more easy using decimal value. 255, 255. Okay, it's I think very easy. Okay. This one is schematic of RGB LED common cathode. I am right? I think you're right. Common cathode. So you just connect in the ground for negative. Okay. So in experiment third experiment, textbook page 110, 111 is the same. RGB LED, red, green, blue, negative, connect to ground. For red, connect pin 11, green, connect pin 10. Remember, this one is timer 2, this one is timer 1, okay? Timer 1. Alright. This one is schematic 11, 10, 9. Red, green, blue. This one is RGB LED. Okay. I think it's no problem with you. just connect directly with the cable because this already built in resistor, so you don't worry about this. But there is kind of RGB LED without resistor. Is you should connect with the resistor, otherwise you destroy your LED. Okay, so in this case we already have resistor in built-in RGB LED, so you just put in directly with the cable. Alright, in textbooks we drive a different color red, green. I'm sorry, this one is blue. This one is blue. I don't update this program. Copy paste. So I think, sorry. Alright, let's go back. So in your textbooks there are function, we call it set RGB. But in textbook is empty, so you should write this analog write for pin R11 and based on the value of R in here. Whatever input is R, you should put in. And analog write pin G and value of G, and analog write pin B, pin 9, value of blue, B. This one. There are 3 value of RGB. Okay, the first is only pin setting, and the void set RGB function to on RGB LED, and the void loop. Void setup. I think we don't need. This one is not necessary to put set the output. It's also working, but if you put the output value for pin mode, also working. So I think you can delete this function. It's not necessary. And in void loop, first is activate rate 255 for here and delay 1 second, and set RGB for green in the middle 255 and delay 1 second. Set RGB for blue, delay 1 second. And in the textbooks LED off, but in this experiment I delete this function. This one not necessary. I think it's not beautiful when you set off the LED. I don't know. I don't like this, so I delete it. So the cyan color, cyan combination between green and blue, and this magenta, red, and what is this, blue, and this one is yellow, red, and green, and white color all is on. Okay, after that there is a for loop. We drive the change the value from red first. When the I is 0, we start from red and then changing the middle color. So from red variation to green. Okay, because this will increase this one becomes 0, and this one become, the final result is like this. First result is 255 0 0. Okay, and then delay 100. This one incremental by 5. Okay, and for loop, second for loop, we drive from green to blue. We start from 0 to 55 first, and then go to blue. 255. Okay, because this one minus I, so will be decreased by 5, and this one will increase until 255. So this one is final result, this one is first result. This will be like this. Okay, I think this one using red is not good. And for third loop, we going to from blue to red. The first begin from 0, 0 to 55 until the value changing to 5500. Okay. In the textbooks, I think delay 20. I change it 100 in here to more slower. And in textbooks, I use LED off, but I delete this function. I think not necessary. So go to the video. I hope you understand for loop. I think it's very easy. This one I explained from first red to green and green to blue, also blue to red. Just like that. Okay. I think we can delete this. I think. Okay. So this one is video. See cyan, magenta, and yellow, white, and then change red to green. From green to blue. From blue to red. And then repeat again. Red, green, blue, cyan, magenta, yellow. Like that. Okay. This one is final experiment from this class. So I hope you understand for RGB LED. Okay. So in here, I already installed RGB LED. This kind of, maybe I should change the cable first. Okay. And the program is this one. It's similar in PPT. First is a pin, of course, and there is function called set RGB based on the value of red, green, and blue. Okay, from 0 to 255 as usual, and then you should analog write in here in red the value of R. So this one is should be like this. Should be, this one is red and this one is green. This one is blue. I wish you understand. Okay, no matter this one. And in void setup, I think this one is not necessary. I think this one, if you use the analog, right, it's always output. So no need this set the output for pin analog. Right? If you use analog, right, you don't need set the output because it's known as output. So no need. Okay, in void loop, red, green. From program, wrong. I just copy from program. Okay, this is white, cyan, magenta, yellow, white, and this one program from red to green. This one from green to blue. This one from blue to red. And last one, in textbook, always off the LED. I think it's not necessary. I delete this. You can do in your home if you can try. And okay, just upload this program. Uploading, compiling sketch. Uploading. So you can see the RGB LED now is on by changing the color, and color is changing. Can you see? I wish turn off the light. It's very, can see the RGB LED changing the color from green, blue, cyan, magenta, yellow, white, and changed red to green, and then green to blue. Something like that. Okay, I think my explanation, if my explanation not clear, you can have question, no matter. Okay, so go back to PPT. This one is video. I mean, go back to program. First is put the input value and set RGB, set up, void loop. Okay, no matter for you. Okay, now homework. I make it easy. I don't want to your life become more difficult. So this homework is basically similar in textbook page 112. Okay. If you have a different book, I think it's same. I wish the same. Anyway, you have to control the pulse width modulation value using potentiometer, and to control the RGB value LED. In this case, if pulse width modulation value less than equal 128, use combination color red and green. Okay, and more than 128, combination color green to blue. This one is pin assignment. Pin assignment is you can use any analog pin for potentiometer and RGB LED using similar pin 11, 10, and 9. And the program is basically this one. So I don't have any comment for this program. Anyway, if the value equal less than 128, the combination color is red and green. I think use this equation, and I think for if this one, I think is not necessary. I think you can delete this. This one is rubbish, because this one is cannot be negative value. Why they set this less than 0 and cannot be more than 255, because you already declare in here the value is maximum 255. So I think no need. Also this one is no need. This one is, but if you want to put in is fine, but I think no need. Alright, so there is no question, I think, because it's similar in textbooks page 112. And this one is video. If we rotate, so the color from red to green, rotate more from green to blue, something like that, right? And if you go back, blue to green and green to red. Okay, very easy, right? I hope you understand. For this homework is, I think, very easy, similar in from textbooks. Okay, thank you for your attention, for attending this class, and I wish you have a good day. Have a good day, and thank you very much.